Now let's move on to next type of a problem. Okay, so here you have some friction also, right? So let's see this problem. The coefficient of static friction mu s between the block A of mass 2 kg and the table as shown in the figure is 0.2. What would be maximum mass value of block B so that two blocks do not move? The string and the pulley are assumed to be smooth and massless. Okay, now what can we do? Let's draw free body diagram. Let's consider B. Okay, so this is B. So weight is acting downwards, then there will be some tension, and it's given that it is not moving. Okay, it is not moving. So what can I say? That this tension will be equal to mg because there is no upwards or downwards acceleration, right? Yes, no. Again, consider A. Okay, let's call this mass of B. Their masses are different. Their masses are different. Let's call this as mass of B multiplied by G. This is mass of B multiplied by G. What about A now? So for A, there is some force acting on this side, okay, and coefficient of static friction is given. That means this force will try to move it towards right, but it's given that it is steady. That means this force is balanced by the frictional force, okay. So this force is balanced by the frictional force, which is Fs, okay. So on this side there is Fs, on this side there is T, okay, tension in the string. So therefore you have T is equal to Fs or Fs is equal to T, okay. And how much is Fs? It is mu multiplied by normal reaction. It is equal to T, and T we found it's equal to mb times G, okay. So mass of B multiplied by G. And how much will be the normal reaction here? It's equal to weight. Right. Mass of A multiplied by G. So you get mu into m1g mag is equal to mb times G. G gets cancelled. Therefore, mu is equal to mb upon ma, and that is equal to, you have mass of A is 2 kg. Oh, sorry. We want to find out mass of B, right? We want to find out mass of B. So it is equal to mu into ma. It is 0.2 multiplied by 2. So 0.4 kgs. This is the answer. Option D. Okay. Now, can we solve this faster? You have this kind of a question. Can you solve this faster? See, what we can do is, this system is there. Okay. You have this mass, some mass on this side, some mass on the other side. Okay. What will happen? If there is some friction, there will be some force on this side. Okay, first of all, suppose there is no friction. Then what will happen? It's like you have just two masses and there is a gravitational force. Okay, downwards gravitational force. So let me explain it to you quickly. Hmm. Hmm. I'm sorry. Where was that problem? This one? Yeah, on this one. Okay. So now, suppose you have this mass and it is resting on this floor. This is frictionless. This is M1 suppose. Okay. This is M1. This is frictionless. There is no friction. Okay. And you have a pulley. There is this rope which is passing over pulley. And you have other mass M2. Right. So this is system of two masses. What is the net force on this system? Just M2 into G. Okay. There will be tension in the string. So tension for this one will be upwards. For this one, it will be towards right. So the string just passes over some force. Okay, right. So see, net force on this system. Forget about this string. Net force is in this direction. How much is that? It is M2 into G. So net force I can say is equal to this mass of the system multiplied by its acceleration. It is M1 plus M2 into A, okay, mass of the system multiplied by its acceleration is equal to M2 times G, okay, when you don't have any friction, okay. So you get acceleration is just equal to M2 upon M1 plus M2 multiplied by G, okay. So this is very simple. After that, okay, after that, what will happen? See, I mean, after that, let's consider a surface with friction. Okay. So suppose there is some friction, right? So now there is some force in this direction, there is some force in the other direction. So you can directly write down, okay, you can directly write down that net force on this system will be equal to mass of the system m1 plus m2, okay, m1 plus m2 multiplied by acceleration. This is the net force, mass into acceleration. It's equal to downwards force, which is m2 times g, minus the friction. How much will be the friction? It will be mu multiplied by normal reaction, which will be equal to m1 times g, okay, and therefore acceleration will be equal to what? M2 into g. G you can take common, m2 into g minus mu times m1 into g divided by m1 plus m2, right? Yes, no? Got it? So see, instead of drawing this free body diagram, okay, this free body diagram, solving these two and getting this, okay, what we can do is we can just write down. So in this case, it was not moving, so two forces are balanced in this case. But suppose there is some acceleration, we can find out in this way only, okay. So if there is no acceleration, then what can you say? If there is no acceleration, in this case there is no acceleration, you can say a force in this direction is just balanced by force in this direction, right? Yes, no? Okay. So this force is pulling this system in this direction, there is another force which is pulling in this direction, they are balanced. So you can directly write down this formula, okay. So frictional force is equal to the downward gravitational force acting on this mass b, and therefore the system is not moving, right? Yes, no? You can save this, okay, you can save this effort, okay. And now remember this, okay, remember this thing what we have done, and we'll solve problems based upon this, okay. So this is a shortcut, okay, please remember this. So we don't need to draw free body diagram in this kind of problems. So see this problem. Now, a system consists of three masses m1, m2 and m3 connected by a spring passing over a pulley P. The mass m1 hangs freely and mass m2 and m3 are on rough horizontal table. This is the rough horizontal table. Coefficient of friction is mu. Pulley is frictionless and of negligible mass, so it will be always there. So the downward acceleration of mass m1 is. So tell me, what should we do? Okay. So see, there is some friction. So as I explained just now, there will be some frictional force on the system. So here you have two masses m2 and m3. Okay, and there will be a gravitational force acting in this direction. Okay, so gravitational force will try to move the system in this direction, and frictional force it will oppose it. So net force will be in this direction. If it is there, net force will be in this direction only. Okay, and it will be equal to this gravitational force minus the opposing frictional force. Okay, so I can say the net force on the system is equal to mass of the system m1 plus m2 plus m3, because if m1 moves with some acceleration, every mass will follow, right, with the same acceleration. Every mass will follow. Okay, so I can say m1 plus m2 plus m3 multiplied by acceleration is equal to, what is the net downward force? It's m1 into g minus, what is the opposing force? It's the frictional force. So it is mu multiplied by the total normal reaction, which is m2 into g plus m3 into g. Got it? Yes, no? Here we did the same thing as I explained. Otherwise, you have to draw three free body diagrams. Okay. So now see, we want to find out acceleration. So let's take this m1, m2, m3 on other side. So we get acceleration equals to m1 times g minus mu times m2 plus m3 multiplied by g. G also we can take common, divided by m1 plus m2 plus m3, and then it's given that m1, m2, m3 are equal. So this is m plus m, 2m we can say, and this is m plus m, this is 3m. So it is equal to m into g minus mu multiplied by 2m into g. Okay, we'll take, okay, let's keep it as it is, divided by 3m, divided by 3m. So then you can take m common and cancel it out. So m, and m will get cancelled out, right? From here I can take m common from the numerator, and in denominator you have m, it will get cancelled out. So what are you left with? Acceleration will be equal to g minus, okay, 2 times mu into g divided by 3. This is the answer. Or if you take g common, it will be 1 minus 2 mu divided by 3. Okay, so it is option D or C. They are same. Okay, C. Sorry. Here you have two. It's option C. Okay, got it? Yes, no? Okay, so here, if you do this, you can save a lot of time. If you don't do this, then this problem will take 5 minutes. Okay, three free body diagrams, you can imagine, right? All right, let's see next one. A block A of mass m1 rests on a horizontal table. A light string connected to it passes over a frictionless pulley at the edge of table, and from its other end, another block B of mass m2 is suspended. So you have a mass m1. Okay, it is resting on a table, and there is a pulley. Okay, a light string connected to it, passes over a frictionless pulley. So this is A, its mass is m1, and there is another mass suspended. So this is B, its mass is m2. The coefficient of kinetic friction between the block and the table is mu k. When the block A is sliding on the table, the tension in the string is. Now you want to find out the tension in the string. Okay. So see, once again, first of all, what we'll do, we want tension in the string. Okay. So I can say I will draw free body diagram of A. So its mass is m1. What are the forces acting on it? Only tension, right? Only tension. Yes, no? Yeah, I'm sorry. There is friction also. Oh, good. There is friction also. Oh, I forgot there is friction. Okay, so there is tension and there is friction also. Okay, so it is T minus F, friction. Okay, and that force will be equal to how much? So the system is accelerating. Yeah, that F is equal to mu multiplied by normal reaction. But this system is accelerating. So I can say, yeah, it is accelerating in this direction. So its mass into acceleration is equal to T minus the frictional force, which is mu multiplied by normal reaction, which will be equal to m1 into g, right? And you want tension, so take this thing on other side. So you get, if you move this on other side, you get m1 into a plus m1 into mu into g. So you can take m1 common, it is a plus mu g, right? Tension is this much. Okay, yes, no? And now what you can do, you can just write down the formula for a. You can say m1 plus m2 multiplied by a will be equal to net downward force m2 into g minus the frictional force, right? So it is m1 mu into m1g. Okay. Move this on other side, so you get acceleration. Okay, so just divide by m1 plus m2, and oh sorry, so we got acceleration. Now just put it here. Okay, so t is equal to mu times g m1 multiplied by mu times g plus acceleration is m2 into g minus mu times m1 into g divided by m1 plus m2, and it's not going outside, no? Yeah, you multiply it out. So it is m1 m2 multiplied by this thing. Okay, so it is m1, you have this m1 outside, mu times m1g plus mu times m2g minus plus this thing m2 into g minus mu times m1g, and in denominator you have m1 plus m2. Okay, so this thing and this thing will get cancelled out. So it is m1 times g plus mu times m2 times g plus mu times m2 times g divided by m1 plus m2, and in okay, multiplied by m1. So yeah, so let's move it on next page. This is still a lengthy question. Was asked in NEET, maybe. Okay. So T is equal to this much. So that was M1 plus M2, right? This thing gets cancelled, and we have M1 multiplied by M2. I can take common, so it is M1 M2, and G also I can take common. So M1 M2 G, and what do I have? Here I have mu, and here I have 1 only. So mu plus 1 divided by M1 plus M2. This is the answer. So let's check option A, right? It's option A. Okay. So see, with the trick also it is taking some time. Okay. So without trick, if you draw the free body diagrams, it will take even lot of time, more time. So if there is a question like this, if directly acceleration is asked, okay, just use the trick, find out the acceleration, right? But if tension etc is asked, you have to do an extra step. Okay, but this is sure shot, right? Yes, no. So you can wait for a time being, like you can solve other questions, and if time is left, you can move on to this question. If acceleration is asked, directly use the formula, okay, and find out acceleration. If this kind of question is there, wait for a time being, because in this much time, in 2 minutes, you can solve maybe two questions or sometimes three questions. Okay, so you need to think. All right, is this thing clear? Is the trick clear? Okay, so don't draw the free body diagrams in exam. Okay, it is not NCERT exam. All right, next question. In the given figure, the pulley is assumed massless and frictionless. So this pulley is massless, doesn't have mass, and it is frictionless too. If the frictional force on the object of mass m is F, then the acceleration in terms of force F will be equal to. Okay, so here pulley is massless, frictionless, and you are exerting some force F on this side. Okay, and then there is a frictional force on this mass which is acting on the other side, on this side, small. Now tell me, what can we do? We want to find out acceleration. This is simple. See, you have a pulley and you are pulling it with force F. Okay, there are two strings connected to the pulley. There will be some tension. Okay, so now the force acting on this pulley is F, and what will pulley do is that it will just transfer this force. Okay, so in this case, I can just say F will be equal to how much? Tell me. Okay. How much is force acting on this side? Is it T or 2T? It's 2T, right? So F will be equal to 2T. Okay, you have pulley. Then this F will be equal to 2T, right? Because pulley is massless. Okay, I will explain that. So F will be equal to 2T. Okay, why so? So in exam, you will just write F equals to 2T, right? So there are two strings, actually one string only, but there is tension in the string. Okay, so both the tension on this side and this side, it is towards left. So total tension you can say is equal to what? 2 times T. Total force towards left is equal to 2 times T. Okay, total force towards right is equal to F, and you will just write F equals to 2T. Why? Because this pulley is massless. Okay, so now you can write down, let's suppose net force is, okay, net force is equal to what? It is equal to F minus 2T. Okay, but it is mass times acceleration, right? It is mass times acceleration. It is F minus 2T. How much is mass? Mass is 0. Okay, mass of this pulley is 0. So what is the pulley doing? It is just transferring the force, okay, to the tension in the string. That's it, nothing else. So this is 0. So F will be equal to 2T. Yes, no? Okay. But from this point onwards, you don't need to do this step. Okay, don't do this step. Just F is equal to 2T. Okay. Then after that, so what about this mass? So there is one tension T acting on this mass, and there is some frictional force F. So it gets accelerated, suppose in this direction. So I can say m into A is equal to T minus F. And how much will be T? So F equals to 2T, therefore T equals to F by 2. Put that. So it is F by 2 minus F is equal to minus small f is m into A. You want acceleration, so take that mass on the other side. So it is capital F by 2 minus F divided by m. It is option B. Got it? Yes, no? Okay, simple question. All right. So let's think about this one. A block of mass m is in contact with the cart C. So this is block M. It is in contact with the cart C as shown in the figure. Coefficient of static friction between the block and cart is mu. The acceleration alpha of the cart that will prevent the block from falling satisfies. Tell me. Yes. What can we do? We have a block of mass M. It is in contact with the cart. This is the cart P as shown in the figure. Coefficient of static friction between the block and the cart is mu. So there is friction between this cart and the block. Now the acceleration alpha of the cart that will prevent. So if you accelerate this cart like this, okay, it will prevent the block from falling. Okay, so we had solved similar question yesterday. There was a cylinder and there was a mass inside that cylinder, a weight, which was okay, which was touching the wall of the cylinder, and then cylinder was rotating. Okay, so with what acceleration should it rotate such that this mass does not fall down? This was the question, right? It's similar. Okay, what will that acceleration do? Provide some normal reaction. Okay, let's think about this mass. Let's think about this mass. So now some weight is acting downwards. How much is weight? M multiplied by G. And there is some frictional force which is acting in this direction, okay, because it is touching the card. So frictional force will act in upwards direction. So how much is that frictional force? It is mu multiplied by normal reaction. And in what direction is the normal reaction acting? It is acting in this direction. Okay, there is normal reaction acting in this direction, right? What will that normal reaction do? So yeah, it is equal to force due to the card. Okay, so we can say if it is not falling, then mg is equal to mu into normal reaction. Okay, or I can say frictional force mu into normal reaction should be greater than or equal to mg, right? Then only it will not fall. Okay, and normal reaction is provided by this card. It is moving with some acceleration. Okay, so uh, force on this mass m will be equal to what? Mass multiplied by the same, right? M times alpha, same acceleration. So let's put that here. So what do we get? We get mu times m times alpha is greater than or equal to mg. Gets cancelled. So mu is, okay, alpha is greater than or equal to g upon mu. This is the answer. Alpha is greater than or equal to g upon mu. So it's option C, right? Yes, no. Problem is simple. Okay. Let's see next one. A block of mass m is placed on a smooth inclined wedge. So this is the mass. It is placed on smooth inclined wedge as shown in the figure. Okay. The wedge is given an acceleration a towards right. It is given some acceleration towards right. Then the relation between a and theta for the block to remain stationary on the wedge is. So this is a smooth table, right? What does it mean? There is no friction, right? Okay. So still it will remain stationary. They are claiming still it will remain stationary. What should we do now? We can find out forces acting on this mass. Okay, M. So I will just redraw this. Okay, I will draw the block like this, edge like this, and block here. Now, see, normal reaction is acting in this direction. It's equal to N. Okay, and then its weight is acting downwards. It is mg, right? Its weight is acting downwards. It's mg. Now, normal reaction will have two components. So what are those two components? So this angle is theta. We can resolve normal reaction. So since this angle is theta, we'll have this angle. Okay. So this angle will be how much? 90 minus theta. This angle theta. This angle 90 minus theta, right? So this angle is theta. Yes, no? Okay. This angle is 90 minus theta. This one is theta. Okay, or we can just say these are alternate angles. So this one and this one are alternate angles. So this angle will also be equal to theta. And then this angle is 90 minus theta. Okay, because this total is 90 degrees. So this angle will be equal to theta. Okay, this angle is theta. So you have n sine theta. Okay, this is n sine theta. and this one will be n cos theta. Okay, so I can say n sin theta. What will n sin theta do? If this wedge is accelerating like this, and because of that there is some normal reaction, so what will the horizontal component of that normal reaction do? It will provide horizontal force, right? How much is that horizontal force? It is accelerating with acceleration a, so it is m times a. Okay. And what will n cos theta do? So n cos theta will be equal to mg. Okay, so you have n sin theta equals to ma, n cos theta equals to mg. So you can find out, I mean, you can cancel out n. Okay, so let's cancel out n. I'm dividing first one by second one, so n gets cancelled out. So you have tan of theta equals to, on right hand side also gets cancelled. So you have a by g, and therefore how much should be the acceleration in order to all of these things happen? It is g tan of theta, right? Yes, no? Okay. So it is option D is the answer. Is this thing clear? Okay. So here we are just drawing the forces acting on this block. Okay. And since the wage is accelerating in this direction, along with the wage, this block will also accelerate in this direction. But what thing will provide that force? This is the question. So you have some normal reaction. You can resolve the normal reaction along two directions. One is the upwards, one is horizontal. Okay. And upwards component of normal reaction will balance mg, the weight, okay, weight of the block. On the horizontal component of the normal reaction, it will provide that acceleration to this block in the horizontal direction, right? So then let us see another question. A block of mass m is placed on a smooth wedge of inclination theta. The whole system is accelerated horizontally so that the block does not slip on the wedge. The force exerted by the wedge on the block will be g is acceleration due to gravity. Force exerted by the wedge on the block will be, okay. This is same question actually, so I will just copy paste this diagram because they have not given any diagram, right? So see the question. A block of mass m, so this is the block of mass m, it is placed on the smooth wedge of inclination theta. Inclination is theta, okay. The whole system is accelerated horizontally so that the block does not slip on the wedge. Block doesn't slip, okay. The force exerted by wedge on the block will be. So which force do we want to find out here? Right. Force exerted by wedge on the block is normal reaction. Okay. So N is equal to what? This is the question. So what should we do? Take the options they are given in terms of, it is mg. All options are in terms of mg. So that means I can say n times of cos theta, the vertical component, is equal to mg. So the normal reaction will be mg divided by cos theta, not mg cos theta, right? So it is also option D. Okay, let's see next question. Again the wage. So wage is also a favorite. Okay, favorite topic. All right. A mass M is placed on a smooth wedge resting on surface without friction. Once the mass is released, this mass is released, the acceleration to be given to the wedge so that M remains at rest, okay, is A. Acceleration which should be given. So now uh, you will give acceleration towards right or towards left. In this direction or this direction. If you give acceleration in this direction, what will happen? It's like you have some mass, okay? This wedge is there, and you are pulling that wedge. So mass will slide down faster, right? So acceleration should be given in this direction only. And how much is the acceleration? So we have found it out. Okay, acceleration is equal to g tan theta, right? Yes, no. Is this thing clear or there is a question? Okay. Is this thing clear? Yes, no? Okay, mic was the problem. All right. So the answer is option A only. Okay. The acceleration is towards left. It should be towards left because otherwise it will slip even faster. Okay. If you pull this wedge on the other side, the block will slip faster. Okay. So it should be towards left and the amount is equal to what? G tan theta. Okay. So it's option A. All right. So then let's see next problem. A heavy uniform chain lies on a horizontal top of a table. If the coefficient of friction between the chain and the table is 0.25, then the maximum percentage of the length of the chain that can hang over one edge of the table is. This is the question. You have heavy uniform chain which lies on a horizontal top of table. Coefficient of friction is given and maximum percentage of length of the chain that can hang over the edge. You have a table like this. Oh, I'm sorry. Table. And there is a chain. There is a chain which is lying on the table. Okay, so this is suppose the chain lying on the table. But some length of this chain, it is hanging over this edge. It is hanging over. Okay. And we want to find out how much is that length in percent. Okay, in percentage. So let's suppose total length. The total length is equal to capital L. Okay, and this much length is suppose L. Okay, this much length is suppose L. So how much will be this much length? So this is total length minus this L, L minus small l. Okay, right? Yes, no? Okay. So suppose now mass of this length is uniformly proportional to, okay, sorry, mass of the length, what did I say? Okay, mass of the chain, right? Mass of the chain is uniformly distributed all over the length. Okay, mass of this chain is uniformly distributed all over the length. So I can compare these two masses. So let's suppose this mass is m1, this mass is m2. So mass is directly proportional to total mass is suppose m. Suppose it is equal to some constant multiplied by length, right? So I can say therefore m1 will be equal to same constant multiplied by this length. Okay, L minus small l, and m2 will be equal to same constant multiplied by this length. How much is this length? L. Okay, and now it is simple. Now we can solve it very easily. So what is net downward force? It is m2 times g. What is force in this direction? It is mu multiplied by normal reaction. Okay, so now these two forces should be balanced. Okay, so the maximum percentage of length of the chain that can hang over the another edge, other edge. Okay, that can just hang over. That means there is no acceleration. If there is no acceleration, then I can say that this force and this force, they are balanced. So m2 into g is equal to mu multiplied by normal reaction. That is mu multiplied by normal reaction is m1 into g. G and g gets cancelled, and then what do you have? m2 equals to, okay, let's put m2 equals to k times this length, and m1 equals to k times this much length. Okay, so you have k times small length small l, it's equal to mu multiplied by m1 is k times length l plus small l, and you can cancel out k also. Okay, so then you have l is equal to mu times capital L minus mu times small l. Okay. And therefore you have, sorry, this was small l, right? This is small l, mu times small l. So let's move this thing on other side. Okay, so let's move this thing on this side. So we get L plus mu times small l is equal to mu times capital L. Okay, you can take small l common. So it is 1 plus mu. You can move that on the other side. You have mu divided by 1 plus mu multiplied by L. Okay, so how much is that? You can put mu equals to 0.25. So let's put mu equals to 0.25. So we have L equals to 0.25 divided by, okay, 0.25 upon 1 plus 0.25, and you want percentage length. Okay, so let's multiply this by 100. So if you multiply this by 100, you get 25 times 100 divided by 125 times L. Okay, that much percentage of L. So that is equal to, this is 1 by 5 and 100 by 5 is 20. So L is 20% of capital L. Okay, So it is option A. Is it clear? Yes, no?